Okay, good morning, everybody. Thanks to attend this complicated multidisciplinary workshop. This is the first for curriculum number 7 in the National PhD on Science, Space, Science and Technology. We are here also in Padova. Why in Padova? Because this workshop and tomorrow are part of a very special, very interesting space lab that I and my colleague Diego Zannoni, we organize in the Master Read, International Relations and Diplomacy, with several activities. And today and tomorrow we have a simulation, or better, we will have not a simulation, but a special meeting on launcher policy in Europe. This is a little change. Why? Because Dr. Diana Shendrikova, for serious health reason, she didn't came in Padova. She apologized, si scusa molto, le dispiace molto anche a me, però per seri motivi di salute che lei mi ha comunicato ieri sera e questa mattina presto non può essere con noi. But we will have the program today with my intervention and then by postdoc fellow Alessio Rocci, and tomorrow with the 2 PhD students, very proud perhaps, but sure very courageous to speak, Andrea Tulli and Sebastiano Ongaro. Why? Because for me it was relevant, important to give them the possibility to launch only a draft of their project, and particularly they are working on 2 articles on Earth observation. We will explain very well tomorrow the relevance of this approach, because they try to apply a special methodology. Then, for me, it's very, frankly speaking, I'm very happy to start this morning and also to speak tomorrow morning, because we have the Science Diplomacy, but also to present a new website, Science Diplomacy Italy, that is now open, and you may search this website. And this is financed by the PRIN 2022, our PRIN, with as principal investigator Professor Leopoldo Nuti in Rome 3, about the search of Europe for an autonomous strategic role. And here in Padua, I am the leader for Padua Unity about space activities, but also with Professor Benedetto Zaccaria for the security and defense questions due to Yugoslavian crisis started at the beginning of 1990s. I advance that we have about 1 hour and 15 minutes, 20 minutes, and we want also to launch a little debate, not only in English, because you are you came from the PhD, okay, and we have a good number of PhD students today with us, but also because we are in Padua, we have some Italian students. They speak very well English, sure, better than me, but I think it's very interesting also to share in our native indigenous language our ideas, because these 2 concepts are very new. I am also happy to see with us Piero Messina. Piero Messina speak about space diplomacy in a very nice intervention in October the last year, and you have on YouTube his intervention during the Science Diplomacy Padua week that you may search on YouTube. And also Piero is our first PhD student for curriculum number 7. We have also other PhD students. And I think this is very interesting. I will speak more tomorrow about the PhD program, but our PhD program is, frankly speaking, unique in Italy, and also, frankly speaking, for this approach on space, economy, law, and diplomacy, very original. Then I will try to share my slide. Space, economy, law, and diplomacy, very original. Okay. Then, I don't know why this we had a little problem. Okay. I think that you see my space diplomacy, a case of history of science diplomacy. Okay. Okay. Few seconds and we solve this problem. I think that you see my of the history of science. Si chiama Mardelli, cos'è la ridondanza, non è? Okay, do you hear me? I hope. Okay. Okay, we start. And space diplomacy, case of history of science diplomacy. I'm sorry for this technical problem, but we want to record this conference and to have this conference not only for the website Science Diplomacy Italy, because we open also another website, Space Diplomacy Italy. Why? As you may see in the logo, we launch just in April a new observatory in Padova University about space diplomacy with an interdisciplinary approach and with the participation not only of several colleagues from Padova, but also other colleagues from other universities in Europe and in Italy. As you will see in our website, the idea is to launch the possibility for students to study, to see how study this type of diplomacy, space and science diplomacy. I underline that space diplomacy and science diplomacy are not cultural diplomacy. Cultural diplomacy is very, very different. It's true that, for instance, in 1970s in Italy, the first science attaché were under the cultural general directorate, but very quickly, like today, they are under the economic division of the Italian embassy. This is to say that when we speak about space, and I think it will be very clear in my last slides, but also when we speak about science, Okay, I'm sorry with the connection, but now we are with you again. Okay, I will share the slides. Okay, I think that now it works. Okay, we have these two new website, as I said, and I invite you to search particularly Science Diplomacy Italy is online, and the other one, Space Diplomacy Italy, will be in the next weeks. The idea of this website is to give to students the sources, the tools to study. This is two new fields of research, and starting by the historical approach, because for us it's very important the history of the evolution of the international system. The idea is to connect colleagues coming from STEM, from the technoscience disciplines, interested in the evolution of international relations. Today is, frankly speaking, necessary, because it is impossible, but also in the past, the real big scientists, they were interested, they were connected. We have several examples, for instance, in Italian history, about several scientists in space activities connected to Italian government, particularly to the Italian Minister for Science and Research, and also connected with the Foreign Affairs Ministry. Today, which is the problem today, to understand, to study, to explain science and space diplomacy? The problem is that foreign policy is not only controlled or managed only by foreign affairs ministers. We have several actors and several dynamics. For this reason, I invite you to search the Science Diplomacy Padova week in October last year on YouTube, because we presented several interventions linked to history, but also on present day. And for space, we have, for instance, Professor Roberto Battiston, and also we had Carlo Baccigalupi, two practitioners, and they made an intervention about space diplomacy. In particularly, Carlo Baccigalupi organized a very nice intervention about big science and the international dimension, international foreign policy. And in
Già.
Okay, and Carlo prepared this intervention after an interview with me. For me, it's very important to explain also the methodology, the cooperation, the collaboration that we have as historians with other colleagues, practitioners of science diplomacy, like, for instance, Professor in Padua Alessandro Paccagnella, the previous Vice Rector for International Relations, Professor in the Department of Engineering, Information Engineering. With Alessandro, we launched 3-4 years ago a special course, master course on microelectronics and geopolitics. Which was the idea? The idea was to put all together students coming from political science and coming from engineering. Why? Because if you want to become a diplomat, or if you want to work in the international dimension, you must, it's not a possibility, it's necessary today, you must to understand, perhaps a little, which are the dynamics of technoscience. it's clear. The example of microelectronics is very simple, evident. Today, microelectronics is in all our life, personal life, but also in the life of state. For space is the same. Space is the fourth dimension of human exploration, okay, with human exploration, the International Space Station, the Artemis agreements, the new moon race, but it's also the place where we have satellites for communication, information, Earth observation, with several implication for security and defense too. And for this reason, today, for instance, Italian Foreign Affairs Ministry has launched since 2022 an acceleration in the number of science attaché and space attaché around the world, about 60. We have 60 science and agricultural attaché, but also space attaché. And this is very important. In Farnesina, in the Italian Foreign Affairs Ministry, we have two bureau, two offices, one for science and agricultural attaché, and the other one created the last year for space attaché. We have only 60 attaché. For instance, United States had more than 250 attaché. In United States, they have also a very special program for PhD students, the possibility for PhD students coming from STEM, but also from political science, to spend 1 year in US Embassy and cooperate with the science attaché, with special rules for secrecy, confidential documents, etc., etc. Okay, United States, but it's very nice when we participate, and I participated in the last 3 years in several schools in Europe about science diplomacy, to hear other European colleagues, our European colleagues, to be wonder about the interest of Italy in science diplomacy, and also about the participation of our science attaché to our school. For instance, they will be online. We have also several interventions and interviews on our school in October last year that we organized in Erice, in Sicily, in the Center Ettore Majorana Foundation, created by the very famous scientist Antonino Zichichi in 1962 for the dialogue behind Iron Curtain. There, since 1960, arrived several scientists coming from East and West to speak all together. And Professor Zichichi accepted last year to launch a new international school, this school on science and diplomacy. You will have some elements in our website, Science Diplomacy Italy. And this is a very nice example also where, for instance, one previous science attaché participate as expert, and also the present science attaché in Italian Embassy in Paris participate in our school with a special intervention. This is very interesting and very nice. Now, I will start from the history with the two very known, because I presented these two cases several times, two cases to explain actors and dynamics in space diplomacy and how space diplomacy may be very relevant. We have here Vito Scalia, the Italian Ministry for Coordination of Scientific and Technological Initiatives. At the time, there were no research and science ministry in Italy. We had a ministry without portafolio, without a special budget. But at the time, 1970s, Italy was a member of the European Space Agency, created in 1975, and there you have Roy Gibson, and Roy Gibson was the general director. He was very surprised, agreeably. This is a personal note by Roy Gibson, discovered in the documents, in the archives of the European Space Agency, hold today in the European Historical Archives in Florence. He was very surprised by the knowledge of Vito Scalia and also the knowledge of his chief of cabinet about the files for the negotiation. Which was the problem? The problem was that Italy put more money than Italy received in exchange. No, in the European Space Agency, we have this very important principle. You put money and you received the same amount of money for industrial production, the national industrial production. At the time, Italy didn't arrive, also for management problem inside the Italian government. Italy didn't arrive to receive the same amount of money for Italian industry. And then Italian minister had to negotiate this situation and to solve this problem. Very complicated. But this is very nice, this slide, and also this note, because we have three actors. No? We have Vito Scalia, the politicians, because also today the political side of this story is very relevant. The politicians have the last word for the decision, in the decision-making process at the national level, also today. Because I remember for you that the European Union has no industrial policy, no? And also European Union has no space policy, a common space policy. Why? Because space, science, and technology are strategic field for national sovereignty. And this is the situation since 1970s up to today. For this reason, national governments were and are relevant also today, but in touch with experts. One expert, one type of expert are diplomats, and you have Umberto Battan. And the interface are the senior official. In this case, Roy Gibson from European Space Agency, but for instance, also today, European Commission has a special directorate, DEFIS, for defense and space affairs. And this is the directorate is an interface with all countries. But we have other type of expert, scientists. But which type of scientist? Gianpietro Puppi, a physicist, is a real model, a real example from Italy as expert. He was a scientist. He had among his students Antonino Zichichi, but also Giancarlo Setti. Giancarlo Setti was an astronomer, very, very important. We will see his role afterwards in negotiation for the Italian participation in the European Southern Observatory. the international side of science, of scientific research, interested to create, to negotiate agreements, and also to negotiate the national participation in international organization. It was not easy for Italy to participate in the European Space Agency. It was not an automatic decision. Italy had to prove to have capabilities for research and for policy at the time. And Professor Puppi had to represent national interest of Italy in this international arena. You may see that also Puppi was one of the creators of the Italian space plan in 1979, and then of the Italian Space Agency. We must know, for instance, that in 1970s, Italy was engaged in a very special debate about the creation of several national plans, all coordinated to the National Economic Plan. The name was the same at the time, Recovery Economic Plan, in order to organize for the first time, in the first half of 1970s, the coordination of industrial production of innovation. And in this general framework, we had several national plans. One of these was about space. And we had also, for instance, for the first time, an Antarctic national plan. An Antarctic national plan. We have also a debate about a national plan on electronics. This is to say that when we speak on, or when we read some articles about Italian national space, this was not original only for space activities, but also for other things. Italy at the time, in the middle of 1970s, was engaged in this debate. Several parties, also in the opposition, were engaged. For instance, Communist Party, Italian Communist Party, had a special representative for electronics. The name was Piero Brezzi, but also for the other fields of science and technology, Communist Party was engaged. How is possible to see the politics, the policy of this party, for instance? You may go in Istituto Gramsci archives in Rome, and they have some documents. At the same time, you may see also the archives of Sturzo Institute, the archives of the Catholic Democratic Party, where they have the files, the papers by Mr. Postal. Postal was a undersecretary in charge of science, technology, and space during 1970s. And this is only to say that now we discover all these sources to study the past of Italy, no? The past techno-science policy in Italy. And this study may suggest us some elements also for the present day. Please cut your microphone. Please cut your microphone. Thanks.
Ma anche portare speciale gruppo, perché non so che vedere. Per esempio, se parlando di un
sì. Okay. Okay, we have here the original documents discovered in one first print in 2017. The original documents no more than 15, 16 pages. This was the Italian space national plan. You have the European program, national program, the different part of the country, a real strong engagement of France and then of the Federal Republic. This is the idea for the budget of Italy since 1979 up to 1983. You may see how was relevant the progression, the acceleration of this plan. But I think the very nice part is about the field where Italy wanted to put money. They are the same today. We are at the end of 1970s. Approximately, they are the same today. Why? Because Italy has no change research, but because Italy there at the time create the opportunities to arrive today and to have a special role in, for instance, big science, for instance, in human exploration. You have the European Program Space Lab, very, very important for Italy. And now Italy is, at global level, a leader in the production of space modules for human exploration. The modules, for instance, of the International Space Station. Last but not least, Italy has also a role very important today for telecommunication, but also for Earth observation. Today, Earth observation is a strategic field for Italy. Last but not least, you may see the number 7, propulsione e mezzi ausiliari di lancio, propulsion and secondary tools for launch. This was the origins of Italian participation in Ariane missile, the big European Space Agency missile, but also the origins of the opportunity for Italy to participate in Vega, the medium missile of the European Space Agency, where Italy is the leading nation. It's very interesting, no? This part for me from an historical point of view, and also for another point of view, the point of view of operational history. Operational history is not a new concept, it's different than public history. Public history is the engagement of historians to share with public opinion the result of historical research. In Italy, we have a very important, very strong specialization for the fascism, anti-fascism studies and resistance studies. You have several examples of public history in this field. Now, operational history is a tool for political decision-making process at the national level, but also at European level. Only one example, we had here an Horizon 2020 project inside, inventing a shared science diplomacy for Europe. The principal investigator was Professor Pascal Griset from Sorbonne University. This project was based on historical research, and then we produce a special report on how history may be useful to suggest some elements for the present decision-making process. This is an example of operational history, and this is possible also for Italian case, not only for Space National Plan, but also for the negotiation for the entry of Italy in the European Space Observatory, where the scientific community, Italian scientific community of astronomers, played a strategic role to convince, to prepare the field for the negotiation, to convince the opportunity, but also the strategic value for Italy to participate in this very important also today organization for space observation from the Earth. The European ESO, European Space Southern Organization. And we have then this report by Livio Gratton, one of the most famous scientists for astronomy at the time. And also we have another very important point. When Amaldi retired and Giancarlo Setti became the new president of the Italian Committee for Physical Science. Giancarlo Setti wanted seriously, strongly, the entry of Italy in ESO. And he was also the president of this very relevant, influent committee. We have here another example, now a committee for science. Also today we have important national scientific institutions. They had a role for influencing Italian policy, not only in national science and research, but also in the international negotiation. They organize with Minister Vito Scalia in Taormina, in this very nice, also today, very prestigious hotel, San Domenico, a very nice weekend in Sicily. The Minister Vito Scalia invited the leader of ESO to speak about the possibility of the entry of Italy in the European Southern Observatory. Who were the participants? Above all, Giancarlo Setti. Then we have the ambassador, but at the time, young diplomat Umberto Vattani, Ludwig Boltier, the president of the European Southern Observatory, the Minister Vito Scalia, and he was not there, but it was very important for the negotiation, Franco Pacini, astronomer from Florence Observatory. All this slide is relevant because we have the actors of science or space diplomacy. In this case, scientists, diplomats, and politicians. Also today, this connection is very important for the diplomatic, the international negotiation about Italian participation in international programs for research and science. The basic point was that Italy had to pay a huge of money, a sort of contribution, to enter in ESO and to cover previous investments made by the other countries. And this money was at the beginning only to pay the investment made by other countries, which was the successful negotiation. The success of these negotiations was that Italy arrived to pay money not for the old infrastructure, but to participate for the new infrastructure that you may see here. Italy participated to the innovation of the European Southern Observatory with money, but also with personnel, with astronomers. And it was not automatic. This was negotiated thanks to the diplomat at the time, Umberto Vattari, thanks also to the determination of the scientists like Pacini and Setti. But this successful operation came from a complex maneuver, not only by scientists, not only by diplomats. Why? Because also today is relevant the participation of all actors in this diplomacy, space or science diplomacy. This is not automatic, an automatic point. Why? Because we have some scientists, also some diplomats or some politicians, which interpretate their role as the primary role, the most relevant role, because they know which is the correct solution, for instance, for global challenges today. We have several scientists now with these ideas. Which is the problem? And here in political science, you know very well. The problem is that science and technology are strategic, but they are in a more general framework, a geopolitical framework, where we have several national interests. And these national interests are the product of several actors, several dynamics, not only science, not only technology. For this is reason, when we speak about science diplomacy or space diplomacy, the analysis is difficult, and our PhD student in our curriculum, they know very well this point, because we must take account several actors, several dynamics coming from different scientific world, in the sense that, this is another very important point, we speak different languages. Because we came from different disciplines. But this is the new frontier of the real interdisciplinary approach. In the past, when I was a younger student, the approach was the interdisciplinary approach made by political science, sociology, law, history. Now, today, we have a new frontiers. We must interconnect, exchange, we must organize workshop, like this workshop, with colleagues coming from different disciplines, from the techno-science discipline. Otherwise, we risk to give, perhaps also is my case today, to give some interpretation, some analysis that stay on the surface, no, of the situation. They don't arrive to touch the real reason of a foreign policy. And this risk is also for our colleague coming from science and technology. This is the law, Italian law, to accept the final negotiation, the entry of Italy in ISO. I put this because you have also, if you want, the archives of the European Southern Observatory. It's a pleasure to quote these archives, but also to suggest to you another point very relevant for the methodology to analyze this diplomacy. These archives are interesting, but are not useful if you use only these archives. You must use also the national archives. European space diplomacy is not told only in the European Space Agency archives. We need to interconnect these archives with the European Union archives and also with national archives. This is to give you very quickly the idea of how is complicated the research in the history of international relations. We must have in mind not only the point of view of the international organization, in this case, European Space Agency, but also the point of view of the different countries engaged. And this is also an invitation to see our discipline, history of international relations, as a discipline who invite to cooperate with other colleagues. Sometimes an historian risks to be too much alone in his room, in his library. No, the history of international relations invite you to go forward to meet the other colleagues, because we need to share our different point of view. Then, and I finish with some slides. This is a very famous image from Bryce Tech Institute. I invite you to see this institute about the global space economy only in 2022. Only this image may give us the idea how the diplomatic side of this story is important. Why? Because in space we have a liberal economy. We have no economy independent from the geopolitical situation on the Earth. It's clear image for you, but we must underline this point. For instance, when we speak about our colleague, the economists who are studying space economy, is not only economy, and not because I am an historian of diplomacy, no, because space is a new dimension of exploration. Only one example, do you remember very well the last year who Elon Musk and SpaceX sustained in the election for the new US president? At the beginning of 2024, who Elon Musk sustained? And then at the end. Why? Because, as I said, also in the last year, Elon Musk is not the leader, the manager of a simple private enterprise. He came from United States, and in United States, for instance, in Seattle, in Washington State, you have two special hills. One is Amazon, and the other one is Boeing. The headquarters of Boeing and the headquarters of Amazon. Why? Because both enterprises must be connected to politicians, to the state representative in the Congress, to the governor. In the United States, we have the lobbying activities. This is typical. And these strategic enterprises are not simple private, also because they are engaged, like Boeing, also Boeing was private, engaged with state procurement system, not only for defense, but also in this case for space. And this is the same situation in Europe. For this reason, it very relevant to study science and technology and foreign policy in political science, but also space diplomacy in political science as a field of application. As you may see, thanks to this slide, space activities are in our life, every moment. Then another slide came from Bryce, the orbital launch sites of the war 2 years ago. Only this image to see how geopolitics is relevant. Where these sites are, in which country, connected which alliance. This is another very relevant point. Obvious after the Russian invasion of Ukraine, when Soyuz, we had no more launcher to use in Europe. And for this reason, Falcon grow up very quickly also, This is an obvious example. Last but not least, 2 other slides, only to give you some ideas. In this case, we have a parallel way. We have Arctic treaties and Artemis Accords. The message of NASA is to say we must to challenge the great successful operation of Antarctic Treaty. I invite you to see the difference between Artemis Accords and Antarctic Treaty. Behind Antarctic Treaty, perhaps, you have a multilateral approach. Behind Artemis Accords, perhaps, you have a bilateral approach. The accords are between NASA and the single government of each country. This is different from a political point of view. This is an example to see also how space diplomacy today is interpreted. Sometimes with too much freedom, and why may be interesting to study the past and the present space diplomacy. Last but not least, Europe. This is to say, this is the last chart of DG DEFIS in charge of defense and space. And this is not hazardous that we have defense, security, and space. Space is perceived by the European Union, the European Commission, as a real strategic new field of exploitation and also of security and defense. This is to say that today the European Union interface is very relevant, not only for big science horizon project, but also because there is inside European Union a debate to develop, to amplify the space activities of the European Union, perhaps in competition with European Space Agency, but also in competition with the national approach, the bilateral agreements between each European countries and other countries engaged in space activities. Italy has agreement with Russia has agreement with Brazil, India, other countries, and China, no? And inside the European Union, we have this approach. Also, this approach, we may study the present situation of space diplomacy, but also the evolution of this diplomacy. And I finish with this remark. In this case, it's very interesting to see the European Union and before the European Economic Community approach to industrial policy. For instance, in 1970s or 1980s, industrial policy and particularly techno-science policy, for instance, in microelectronics. At the time, they didn't speak about space, but they speak about some advanced technologies like microelectronics. And it may be interesting to see which was the philosophy at the time decided by the European countries, the intergovernmental approach outside the framework of the community, the European community, to have the maximum of freedom to engage in negotiation with the third countries outside Europe. At the time, above all, United States. Why? Because at the time, and also today, technoscience are perceived as a strategic field of sovereignty. This attention to technoscience in the European Union help us also to suggest to our colleagues studying the European integration process that, okay, we have the political debate, very interesting. We have the debate about economic rules, but behind this debate, the debate on technoscience may be very interesting to see the real strategy of each country. And this is very interesting, very relevant also on defense debate today, because behind defense policy, we have armaments production, armaments cooperation in Europe, and we have an evolution. It's not hazardous today that Germany and France are really interested in rearmament, in the rearmament of Europe. They are constructing a strategy for armaments production since 1950s, 1960s. And this point may be useful also to interpretate, to see the evolution of space diplomacy. Thanks so much, and I'm sorry for the technical problem. Now I would pass, I would share the floor with Dr. Rocci, and we will have at the end a question time, if you want, a debate, also in our room. You have the floor. In bocca al lupo.
Vediamo. Ok. E questa. Vediamo. In the meantime, I would like to remind you, please, in the online, to write again your family name and name to track your presence here. Yeah, here it is. Okay. No. This here. Okay. Prima condividi. Ok. Do. Okay, so where's the share?
The green one.
This one.
Yes.
Okay. Ok.
Condividi.
Ok.
Okay, next.
Ok.
No.
Ok.
Di fare un di schermo
Mhm.
e dopo fai metti in presentazione.
Condividi schermo. Quale? Sei in condivisione schermo. Sono in condivisione schermo. Io sono in condivisione.
È già in condivisione schermo.
Vieni a vedere,
No.
io sono in condivisione schermo. Solo che la visualizzazione è diversa. Ma fa così.
Okay, thanks. You have the floor.
Okay, thank you very much.
For your intervention about quantum connection, the growing importance of quantum in science diplomacy. This is also a draft of a project. And we met Alessio Rocci in our network on science diplomacy, and she is a fellow in the University of Brussels, Libre Université Bruxelles, and now he is a fellow here in our department for the new course, the next academic year, History of Science Diplomacy. Because in the next year we have a unique course in Italy, this course, History of Science Diplomacy, and Alessio will be a fellow in this course. He's a specialist of Solvay archives, and we may see that he's writing, is reflecting now, so a new project. Thanks so much, and you have the floor.
Thank you. Okay. Thank you everyone. Thank you, Professor Burigana, for this opportunity to speak with you all. So my topic today is about the concept of quantum in general, and I was thinking about it because in my previous postdoctoral fellowship I considered the history of quantum because my background is as a physicist and history of physics and science. So, but I started to work with the International Solvay Institutes, which is non-governmental institution in Brussels, and the University Bruxelles. And I started to study the history of what is usually called the first quantum revolution. I will be more clear later about it. So, and then I realized that this year UNESCO declared the year of quantum science and technology. So the question that my starting question was to myself, why did they do this, and what was the reason behind this choice? So the very first reason you find in the web about this declaration is that 100 years passed from this first revolution, or maybe a little bit more, because in history of science we usually say that the first quantum revolution of the quantum revolution in general started at the beginning of the 20th century. So in there was the introduction of this new concept, which very few people know about. So why was my first question, and the other question was, does this choice of UNESCO matter to society? Does this matter to scientists, to politicians, or diplomats? Okay, so if you try to understand this anniversary, you can find on Nature some articles saying that 2025 was the International Year of Quantum Science and Technology. This recognizes the 100 years since the initial development of quantum mechanics, which was a very new theory, this revolutionary theory, maybe born in 1925. So But this is not really true. So 1925 was just one moment when a famous scientist, Werner Heisenberg, published a paper, which is not the beginning, neither the beginning nor the end of this theory called quantum theory. So it was a revolution, but the process was a bit more complicated. My point of view as a historian of science was that the quantum revolution really started in 1911 with what is called the first Solvay Council. You can see a very famous picture where there are many famous scientists like Albert Einstein, Marie Curie, or other maybe less famous like Henri Poincaré and so on. And a very nice picture of maybe one of the first examples of Photoshop in history, because the philanthropist that started this project, Ernest Solvay, who also started the company which is famous for the engineering of soda and other things, he abandoned the idea to be an industrialist, and he wanted to support science. So he was not, he was what is called scientific philanthropist, and he started this this endeavor. And at the first council, it was clear that the old idea of physics were completely were wrong in the microscopic world, so they needed some new ideas. And as you can see, on the other end, we have what is usually what Werner Heisenberg called the completion, the moment when we had the completion of quantum mechanics, when the theory was in a sense complete and ready to work with examples. And there was another council, a physics council. So the whole process took a lot of time. It was not just 1925, so it's not exactly 100 years. And the big protagonist is of this endeavor was the Solvay Institute. This council were a stage where scientists discussed many things about physics, but it also was a moment, an important moment for the international relation, because it was the moment when the internationalism movement, especially in Brussels, gave birth to the Solvay International Institute. It was a special place because Brussels was a place where many international communities were established. There were no national important national scientists in Belgium about physics, so an international committee was needed. In this sense, I would say, well, 1925 is not really the good starting point. So my reference frame, so this is why I was telling you about this Solvay Institute, is the situation of the experience, so the case of the International Solvay Institute. It is what in physics is usually called the reference frame, because the three aspects were mixed, especially in the period before the First World War, and then many things happened. I don't have time to tell you everything about that, but these three dimensions, the science, the politics, and society, were mixed up in the why, for example. But we have to remember that the actions made by this kind of actor, the non-state actor in science diplomacy, an individual organization that has significant political influence but is not allied to any particular country or state, are very important as well. So what did this International Solvay Institute do in the past? So why this is important to me? Well, they had an international scientific committee who, as you can see from the slide, was interested both in the international and the national side. Because internationalism, as is well known, is a movement that was created to to stimulate the international cooperation, but as also Professor Burigana said, it has a second it has a second attached consequence, that you can try to advance international interest, but you also are advancing national interest. And so inside the International Solvay Institute, both the international side and the national side were interesting. So you have also, and then you have the connection with the public, because they were making conferences and they were organizing this council with this International Scientific Commission, but they were also giving subsidies. And this is a very, very poor known notion. So this stimulation of national and international interest from a non-governative association was very interesting. So this now you understand why, as a historian of science, I started to be interested in the international relation from this side, from the side of the international, of the history of science in general. The concept of science diplomacy is a bit is not new, and is usually a mix of three concepts. One of these is the science for diplomacy concept, which is according to the Royal Society definition of 2011, I think so, is the use of science as a soft power to advance diplomatic objectives for building bridges between nations. So science for diplomacy encompasses cooperation agreements, as we say, the creation of new institutions, and on this side, the creation of the Solvay Institute was a sort of science for diplomacy act. When we have educational scholarship, and when we have what is called track to diplomacy. I mean, the action that this kind of actors, the NSA actors, can do in this context. So I give you one example of what happened in the interwar period, I mean, between the First World War and the Second World War. As you may, of course, know, Germany lost the war. So at some point, the German scientists were banned from many activities. So this is okay. And there's I think I forgot one. Okay, so there was a problem, and the Allied science, the Allied nation didn't want to have nothing to do with German scientists, and especially Belgium was very, very against in general, because, as you may know, that there was a lot of bad things happened in the frontier between Belgium and Germany, with all that happened about the development of chemical weapons and so on. Not only about the violation of Belgian neutrality, for example. But so German scientists were banned, as maybe usually happen today with Russian scientists. And but at the beginning, Ernest Solvay, who at the time was still alive, he was not really convinced about this fact. So they decided that all the members of the international committee had to resign. So they have to re-elect a new international committee, and they left open the possibility to the German scientists to be admitted again in the context of the Solvay Council. A lot happens in between the two wars in this interwar period. One interesting point is that well before German scientists, before Germany was readmitted to the League of Nations, then just before this event, the chair of the committee decided to speak with the Belgian king, because many developments about physics had happened, and it was impossible to speak about the concept of quantum without German scientists. So they needed them in the context of the Solvay Council. And he convinced the king that this was really important, that now Germany was going to be readmitted in the League of Nations, and then it was time to readmit them also in the stage of the Solvay councils. But this was not easy, because there are traces in the Solvay archives that at the time, I mean, in 1927, when the Fifth Council was going to happen, that there were a risk of public demonstration in Brussels, because, of course, people, Bruxellois, were still against the return of Germans. But in the end, everything went well, and we had this council. So I wanted to tell this story because for two things. First, because I wanted to show you that it seems a bit strange to say that 2025 is 100 years after the quantum revolution, after the first quantum revolution, and from another side to present you this the stage of the Solvay Institute and the Solvay Council. But so if it's not exactly 100 here, why are we celebrating this year the year of quantum? What's behind? So if you really go to investigate what was the real motivation of UNESCO for electing 2025 as the year of international science and technology, according to the proclamation, this year-long worldwide initiative will be observed through activities at all levels aimed at increasing public awareness of the importance of quantum science and application. And so I was thinking, well, maybe the Germans wanted this year to be the year of quantum, and I discovered that the first act came from the permanent delegation of Mexico at the UNESCO. Ana Maria Chetto wrote a paper where she recounted about the need for this declaration, and so the real point is not about the history, but is about the fact that quantum is going to grow in its importance for all of us. I mean, not only for the scientists. Then it makes sense to ask to myself, where this growing importance start? When this growing process started? Why, more or less? And trying to understand if it's now important not only for scientists but also for the rest of the actors that we mentioned. Okay, so let's read this with me, this point. So in this article, Ana Maria Chetto says quantum science has been the forefront of major technological innovation across many fields in recent decades. So this so-called first revolution, and I want to specify that as first revolution, I would say is the first period of the quantum revolution. So this first revolution, the one that I told you about, has continued to evolve and remains a vibrant and expanding field. Today, we use quantum physics in our everyday lives. You know, smartphones, everything works with that. But for example, we also have integrated lasers, compact batteries that have transformed communication and medicine, improving the quality of life for billions of people around the world. Quantum theory is at the heart of our life emitting and blah, blah, and so on. The real central point for us is what I squared with the red square. Despite all the progress made in recent decades and the enormous expectation, the scientific term quantum is still unfamiliar to most people, including decision makers, who often find it difficult to understand. It is therefore essential to raise awareness of the importance of quantum science among policymakers and the general public, and to inspire young people to become the next generation of quantum pioneers. So the real point for this year of UNESCO was not to celebrate 100 years of history, but just to have an impact on the society and on the policymakers. So to understand why everything is growing and what really happens, I have to bother you a bit more with physics and other things that happened after this first quantum revolution. Because in 1927, a lot of things were really clear. It's true that this new theory about quantum, the double nature about the wave and the particle nature of light or electrons and the microscopic world, well, not everything was really clear. One thing that was not perfectly clear is what we call the quantum weirdness. I mean, when we usually look at the world, we see clearly that to, for example, exchange information needs time. So when we send a signal on the moon, we need to wait time to have it back. So everything needs time to exchange. The information needs time to be exchanged. In the microscopic world, the exchange of information, it's a bit different because there is a new phenomenon that we don't experience at the macroscopic world, which is called entanglement. And the idea of entanglement, more or less, is that you can create two different particles and put them at a very long distance, and then you can discover something about what happens at a very long distance, knowing what is happening here. So it really is a sort of mechanism to connect at a very long distance. But I wouldn't enter in the specific with this. Just to say that the paper that for the first time was telling about this phenomenon, entanglement, was published in 1935. So after 27, a lot of things happened, and then in this period, physics was more concerned about the idea of making calculation, discovering things, and they had the motto that was called "shut up and calculate." They didn't want physicists didn't want to have nothing to do with philosophical things and so on. But in the mid-60s, another physicist, John Bell, discovered that it is possible to check for this quantum weirdness, and he published a paper where he explained how, more or less, you can make an experiment to test this. And then when this test was really made, well, the test was really made. It took a long time to make this kind of test, so to see this entanglement between photons, I mean the quantum of lights, and see that was happened around the 90s. So the 1990s, more or less, many other experiments started to be used. So it was clear that this quantum it was clear for physicists, of course, but there was a growing interest in the big community about this idea of entanglement. I'm speaking about a very small community who was working about this. But this growing community, this community grew a lot between the 1990s and the 2000s. So, for example, there were a lot of actions in the middle that we see in effort today. So, if you Google about what is doing Google about the quantum, you will discover that they're speaking about quantum computers. They're speaking about quantum computing. So, is this real? Is there really something that is doable? Well, it is real. So, quantum computer exists. The point is that they're not working like the computers that we know, that you have now. I mean, the computers that you have use a lot of workforces. And the workforces for computers are called, usual computers are called bits. We have a lot of bits in working in these computers. In the quantum computers we now have, we have very less computers. We have other workforces, which are called qubits, from the contraction of quantum bits. And we are working with very few quantum bits, so around 1,000 more or less now. So, but there was in 2016 a manifesto, a quantum manifesto, as you can see, who was based on 4 pillars, which is communication, simulators, sensors, and computer. So the idea of quantum, the idea of quantum technology, which now is different in this sense. It's not the same aspect that we had in 1930s. This is more about the technology applied. Okay, so, and this is one reason why we call it second revolution instead of first. So, does this technology matters for diplomats and so on? Well, it does. So, I started to speak, as Professor Burigana said. One of the interesting things about consider history of science mixed with history of international relations and so on is that you're not working alone in your office, but you're going out to see what other colleagues say. And I had, I would say, not an interview, but a friendly talk with Professor Simone Montangero, who is in charge at the University of Padova at the physics department. So we were speaking about the idea of the quantum, and I was asking him when this idea started to grow at the European level. So not at the national level, but in the center where international interests are cooked up. Challenge the computer scientists, and he said in a very famous talk, nature isn't classical, damn it. And if you want to make a simulation of nature, of how really nature works, you'd better make it quantum mechanical. So the idea was, okay, we are in a society where computer is very important, but this computer that we have are classical. If you want to simulate what happened in the microscopic world, maybe you need a quantum computer. And in 1985, David Deutsch formalized the notion of this quantum computer. And finally, you have in 1993, Seth Lloyd published a paper on science, which was a potentially realizable quantum computer. So scientists were sure that this kind of quantum computer could be made, okay, could be built. But of course, that was true in the local laboratory. They needed more money, they needed more, a higher level to develop different technology, to develop this technology. But the real growing moment, the real moment when the importance of this idea of quantum started to be shared with politicians was, of course, when it started to touch the money that we have. And in 1995, Peter Shor, a computer scientist and physicist, published a paper when he developed what is called the Shor algorithm. So please, let me spend a couple of 1 minute to tell you what is this about. So you all have a credit card in your pocket, I think so, right? So, and maybe very usually you use it to pay something or with the mobile, okay? And the data that are exchanged between your card and the bank account, these data are exchanged using what is called an RSA algorithm. So, and the acronym RSA comes from the family names of the 3 scientists that invented it in the 70s, okay? What is the point? That you don't want to give your money to other people, right? So you want that your money, you want to pay you don't want you to lose your money. So the point is that when you exchange information. And then we come to this idea of exchanging information. When you exchange information, you don't want this kind of information be caught by someone else. So these data are usually encrypted. How are they encrypted? With what is called the RSA algorithm. So they are hidden. It's not impossible to break this algorithm and know something about your bank account, but it would take more time than the age of the universe. So the basic point behind the RSA encryption algorithm is that it would take 2 times to understand to rob your money. Okay, but here's the real breakthrough. When Peter Shor wrote this algorithm, he discovered what is now called the quantum advantage. I mean, this is the idea that the time that would take a quantum computer to break the RSA algorithm is not very long. So it would be the case that if we develop a quantum algorithm, we could break this RSA algorithm, and essentially I can rob you. So I can enter and disencrypt your bank account and try to have your money. So everything was potentially at risk. And well, on one side, it was not easy to make aware politician and other decision maker that it was an important moment. So as usual, there was a time between the reception of the scientific idea and how the money were put. So this time was more or less 2-3 years. At the time, in the 1996, there was a special commission in European science. It's called the European Science Foundation. It's a foundation with the different scientists, and this foundation was working on the development of what is called the framework program, the Horizon 2020, and all other programs we benefit to make research and so on to advance the science and technology in Europe are all framework programs. And at the time, the 4th framework program was aimed to contribute to society's needs to science and technology and support the community's common policies. So this group of scientists had the duty to study how to go beyond this framework program. It was a period where the European Union started to understand to invest a lot of money in the digitization and in the digital society. We are, you are sons of the digital information society. So in that moment, the European Union started to develop this aspect. As you can see, there is a document in the archives of the European Union in Florence, where this development was presented. This is a part of a document which was a summary of presentation given at the public hearing of the European Research and Development in October '96. So if you take a look at this document, you will see that they were receiving from the scientists the idea that there were progress in several areas. I'm reading progress in several areas of the physical sciences, and that Europe needs to be prepared to anticipate and exploit all this. And physical effects ranging from linear and non-linear optical effects and quantum confined effects were important. So the production of new devices based on these effects requires the controlled synthesis and characterization of solids and blah blah. So it was important to envision a new plan to expand European Union in this direction. You have to remember that we lost our battle about the computers. There is just Professor Professor Montangero remembered me that there is only one company building computers in Europe. There is, which is in France, not in Italy. We don't have the technology. We need the technology, so we ask for it. So the idea was try to have something more in Europe. What is the European? And this kind of scientists, they try to put in print what was the European added value of this operation. They say support will be needed at level for the development of algorithms for systems and software, and consolidate and improve the competitiveness of European industry, not only in this area where no country has the means to be at the cutting edge of research and development by itself. More importantly, all countries share a pressing needs for skills in mathematical modeling. So, as you can see, the building of this part of the framework program was to use science to advance the European European cooperation between the national beyond the national level. Well, and this is the reason they try to strengthen the European solidarities in science. So all this effort was not really didn't succeed so much in general. There were good points and bad points. So at some point in 1998, the Commission, the EU Commission approved a new plan, which indeed was about the quantum information theory and the quantum computation. So the importance of new idea of quantum, the introduction of the quantum in the context of the computer and in the context of the communication started to be relevant for the European policy, for the science policy in Europe, for the investment. And the people that that participate in this document are also the one that became the Nobel Prize in physics, the physics of communication. But as you may know, to involve society and to involve also other actors, you need important stages. And there we are again in the Solvay Institute stage, because the Solvay councils are still held nowadays, and they continue to be held every 3 years. The councils in physics. And soon after this plan, in 2001, there was a council dedicated to this topic, the physics of communication and the growing idea of quantum. I won't spend so much time telling you that in this period, the Solvay Institutes, the director, at the time director of the Solvay Institute, which is called was called Ilya Prigozhin, a Russian guy that ran off from Russia in Brussels. Well, at the time they started to have this council not in Brussels but in different countries. So in the 80s they moved first in the United States and then in other cities of Europe, again for political reasons. Well, in 2001, this council was held in Athens, and in Athens, among the different scientific reports that they have, one of the reports was about the challenge in ambient intelligence and what was happening at the European level. So one talk was presenting the new framework program, and what was at the time the emergent importance of the idea of quantum and this quantum technology. One of the reports I discovered speaking with Montangero was presented by his mentor, so the professor he was working with. At the time, Professor Montangero was a PhD student. He basically finished his PhD, and he told me that a lot of the things that in fact, his name is inside the quotation. As you can see, what is important for the European scene in the end of the 1990s. And everything started to grow. So the scientists invented a sort of first action in 2003, and the action that they started in these years with other frameworks, so with the following frameworks program, resulted in which is called the Quantum Manifesto for the Euro. And here you have what were the medium-term goals in 5-10 years. So a good point for what happened in the European Union at the level of the European Union is that we started all this collaboration, and for example, the European Science Foundation also analyzed how these collaborations were made, and they recorded that, in fact, it was easier to do some bilateral agreements. So in Europe, we are better in making bilateral agreement than multilateral, for example. So there was a huge difference between the two. So in the Quantum Manifesto, one of the voice was to demonstrate the ground-to-satellite quantum cryptography. So the point is that we try to exchange photons, what physicists usually call entangled particle, for safe communication on Earth. But as far as we see, it would be better to try to establish a communication between the ground and satellite. So one of the aim of this manifesto, of this movement, was to extend this kind of technology to space and try to see if we can have this technology before other people. In fact, the fourth framework work I mentioned already started to stimulate this process. And we have, and here you can see a report, the executive summary report, presented by Markus Aspermeyer and the Nobel Prize in Physics Anton Zeilinger. As you can see, the core of all this innovation was in Austria. Okay, and they presented a report when we analyzed this possibility that was already made in 2003. There is also a paper coming a bit later, presented by Paolo Villoresi, again another person on the University of Padova, with Anton Zeilinger. Okay, and they wanted, I'm reading with you, extending quantum communication to space environments would enable to perform fundamental experiments in quantum physics, as well as application of quantum information at planetary and interplanetary scales. Here we report the first experimental implementation of a scheme of single photon exchange. So, I mean, one single qubit instead of the many that we need to break the algorithm that we say. On the right hand side, you can see that it's mentioned the contract that they had with the European Space Agency, the quantum communication in space, and so on, to develop this. Okay, so there was a lot of effort at the European level to try to go on with to develop this kind. Who was the first to implement ground satellites quantum cryptography? Would you say Europe?
China.
Yes, China. And more or less in the very same year, 2016, China successfully launched the world's first quantum satellite, MOSI. So and they started to work about it on it in 2011. So they also have this kind. So we have this now. We have this problem in development. Maybe this was like a lost opportunity for Europe, or maybe not. I don't know. but it's clear that something has clearly gone wrong for you in the collaboration, in the implementation of the international collaboration, and so on. Here we are now. So now we arrive this year, today, in the 30th of January in Brussels, the ESA and the European Commission consolidated their cooperation on the European quantum communication infrastructure. So quantum, again, is growing its importance in the context of what is going on at the European level, but also at the national level. As we say, speaking with Professor Montaggero, he told me that he recently went to Paris to have another bilateral agreement between Italy and France to try to build this collaboration, because we don't want that this technology, as in normal computer science, classical, we'll say, computer science, could run away. So, and yes, he admitted that in a sort of sense, it's very difficult for a scientist to know how these things work. It takes time. So, again, we have the quantum declaration, the European Commission. After all this act, after the quantum manifesto, we now have to decide how to go on with all of this. And on December 23, the presence of the European Commissioner for International Market, Thierry Breton, the Spanish presidency issued a declaration to strengthen collaboration among the member states. So it's this is to all this is to show you how it's very important for the 11 member states to endorse this declaration, to strengthen all the links between the single nation and at the European level. This is another local example of what is happening. The Istituto Nazionale di Fisica Nucleare, INFN, recently signed an agreement with an ambassador in Canada. So, but again, as you can see, we have some non-state actor like INFN making agreement with another country. It seems that we don't have a sort of national organism speaking up for Italy in the international context. In fact, there is not. So we just have something that must be built on. So let's see what happens in the following year. Okay. So my final slides are about thinking about this. So the quantum is a concept that is now an important actor in the development of international cooperation. There is an increasing need for interdisciplinary teams where scientists, diplomats, and historians could meet and discuss past, I would say, because we are historians, present and future strategy on science diplomacy. And I say it's especially in the context of quantum technology. Well, there is no one is teaching scientists how things work. So I think that this kind of workshop would be interesting to discuss about that. So I would like to also to hear from you what you think about it. My question is, were you aware about this growing importance of quantum? What do you think about this interaction and other things? So thank you for listening, and say hi to my version of the Schrödinger. Thank you.
Okay, we have a little question time if you want.
Yeah. Okay.
Resti lei, io mi sono qui.
Accento l'attenzione.
No, mi tocca a lei questo. Okay, if you have any question or also in Italian,
Yep.
or in the chat, because we have about some people coming from PhD, national PhD, may be interesting. If you have any question, we have about okay, some minutes. Yes, we have the time.
Okay.
Or anyway, if you have any question in the room, also in Italian, because we are in Italy. In Italy, Padova is different than Italy, but also okay. Infatti,
Professore, ma il fatto che effettivamente l'Europa, diciamo, non sia ancora riuscita a lanciare un satellite quantico, quindi comunque nonostante si sia operata anche prima gli altri, proprio non so bene no? A ricercare di adoperare questa tecnologia quantica, è dovuto al fatto comunque sempre rilevante della frammentazione della leadership, e quindi è per questo che la Cina è riuscita ad arrivare prima, o ci sono state delle interferenze tra i vari stati o comunque di questo genere?
In italiano o in inglese rispondo?
As you want.
Okay.
The question is not easy.
Okay. Well, the question is about what happened, why things went wrong. Okay. Well, it's a good question.
Why Europe didn't arrive to launch the
quantum satellite.
China, yes. And why? Perhaps because we have a conflict of national interest in Europe.
Well, I don't have an answer now, okay? And I say I don't have it now because one idea would be to try to continue to investigate this perspective and try to understand what we can learn about it. Well, as far as I can see, in general, in Europe, as I said, we usually are better in developing, as scientists, we are better in developing bilateral agreements. And if you really want to build this kind of satellites and launch these satellites and organize all this to work, I think you need a lot of money. So you can have two different approaches. If you are sitting on a bunch of money, you can use it and in the private sector. Our private sector is not so developed as in China or maybe in the US, for example. So we really need to cooperate on a multilateral level. So one state or two states are not sufficient enough to develop this kind of technology. So my guess is that one point would be that the lack of multilateral agreements in general. This could be one reason. But this should be investigated. It's not so easy to investigate this topic for two reasons. One is because you should, of course, know more about what happened in China. I don't think this would be very easy to investigate. And on the other side, you also would like to know more about what happened with the contracts of the ESA. What happened between the moment that the contract was terminated, why was terminated, and what happened. Again, we have some documents also of the ESA archive which are not allowed to. We have a restriction until 2030, so on. So as a historian, we need to fight with all these things. I'm saying this because we are speaking also about methodology, right? So this is one of the things that we need to face when we go and visit an historical archive. So this is one thing. But as science politics practitioners, we can also observe what are doing the ESA, the EU Commission now, and try to understand, try to judge, try to predict what is going to happen. Okay, I didn't mention that in the context of science politics, there is also a very nice initiative that was started 2 years ago at the CERN, a new institute which is called the Open Quantum Institute, which is basically a spin-off of the Quantum Lab of CERN, but it is a place where practitioners of science politics, diplomats, and so on are discussing about the connection between the quantum and how life could be with new quantum technology, because we could have new sensors, new things, and they also developed a serious game to try to understand how to negotiate, how to develop these things, how to work as science diplomats, maybe quantum diplomats, I don't know. So it is a field where we need to try to understand how to negotiate position, how at both the bilateral, multilateral, international, at the EU level. So there are many layers to be considered in the context. I don't know if I answered.
No, ho capito. Cioè, sicuramente ci sono molti fattori che
Sì.
non possiamo ancora conoscere, quindi diciamo che magari fra qualche anno.
È una domanda aperta,
Esatto.
che è un possibile programma di ricerca, volendo.
Però ci sono già delle risposte, but I must reply in
Yeah.
English. So. Do you have any other question, remarks, or you let me a last remarks? Thanks so much for your draft, and sometimes, a volte, no, una risposta, glielo dico in italiano, poi cerco di tradurlo in inglese, una risposta a quello che lei ha chiesto è quello che suggerivo prima io, no? Siamo abituati che uno studia il lato politico, ci inserisce le questioni economiche, poi c'è scienza e tecnologia, e si ha la tendenza, ma è una frontiera nuova, a non studiare più scienza e tecnologia, solo la fisica, solo lo spazio, solo la microelettronica, ma cercare di studiarli in parallelo. Allora si viene a scoprire, per esempio, che questa idea di fare degli accordi bilaterali è un'idea che viene dall'evoluzione dell'Unione Europea. L'Unione Europea non è la comunità europea. Nella comunità europea, fino al 92, si faceva un progetto e tutti potevano o dovevano partecipare. Oggi con l'Unione Europea si ha, lo dovreste sapere, la geometria variabile, quindi la possibilità di partecipare o non partecipare a un progetto. Non c'è solo la possibilità, ci sono anche delle regole per poter partecipare. Cioè si va in un progetto se si hanno le capabilities e il denaro, altrimenti questo non è possibile. E molto spesso, soprattutto per queste questioni strategiche, si decide una via bilaterale che preserva sempre il controllo nazionale sulla tecnologia. Questo è il limite dell'Unione Europea rispetto agli Stati Uniti. Noi si fa sempre un confronto anche dei colleghi stranieri che non hanno la percezione del processo di integrazione europea, fanno un confronto tra Stati Uniti e Europa, ma di qua non c'è l'Europa, c'è l'Unione Europea e mancano delle politiche, ci manca una politica industriale. Gli Stati Uniti invece hanno un sistema di mercato, come lo abbiamo noi, però poi hanno un'amministrazione federale. In Cina, ovviamente, tutto questo è moltiplicato all'ennesima potenza perché in Cina esiste un regime. Quindi c'è una decisione piramidale che poi diventa molto efficiente. Però c'è una presa di decisione unica che da noi non c'è. E quindi I thank so much your intervention because, for instance, no, Dr. Rocci suggests in 1926 we have for the first time all scientists of Europe all together. Why? Because we have the political side here. The political side is 1926, the entry of the Germany in the League of Nations in September 1926. We have several pacts of non-aggression. We have the Brian Kellogg Pact 1925 for the peace in Europe. We have a relaxed international context, a peaceful international context. Because if you see the documents during the Versailles negotiation after the end of the First World War, the documents from, for instance, the French Academy of Science, the French scientists wanted to exclude from Europe, from the new European network of scientists, the scientists coming from Germany and Austria. Why? Because they condemned them because this is German scientists, sustained Germany in the First World War. When the idea started to organize a network of CNR, the National Research Center, this idea started from the US administration. A scientist, the name was George Hilary Hale, and he exported this idea. The idea to organize a network of scientists in Europe with USA after the end of the Second World War, but by excluding Germans. For instance, Einstein. This is a good example of science diplomacy in a better sense. He quote in the document of Anna Maria Zeto the relationship between experts, the politicians. Anna Maria Zeto declared, politicians, they don't understand quantum. But why? Because the problem is the relationship between expert scientists as advisor and political decision makers. We have in Europe some example of this, but very a few examples, not so many examples. This is very important. For instance, our school in 2021 started in cooperation with my colleague Maria, the Professor Gala in Rome 3. The idea was to organize school on the interplay between scientists and politicians. This is necessary. It's very nice to see the same problem today for quantum, because quantum is a strategic field. Last but not least, the idea of bilateral agreement, because in Europe we have this possibility to make bilateral agreements on strategic fields. This is not a successful of European integration, frankly speaking, no? In this sense, it's very nice because he is not an historian of European integration, but he helps us, historian of European integration, to understand, thanks to technoscience, which are the limits. Because when we speak about defense policy in Europe, we must have in mind that we have also the techno side of this, the techno-science side of this policy, not only the political debate. We need to understand the technical problem, the industrial problem. And sometimes also some historians of European integration don't care this side. But it's not useful to speak about defense European Union when we don't know how a tank works, how a tank is produced, when we condemn Germany or France because they wanted to rearm Europe. They started in 1950s and they reinforced their policy for common armaments production in 1980s, 1990s, not in the last weeks. It's clear then Berlin and Paris want to be the leader for the armaments in Europe, not Italy. Why? Because Italy don't invest in tanks, in armaments cooperation. Only for few examples. Why? Because we are linked to a great alliance, Atlantic Alliance. We have a very nice strategic cooperation with the United States in NATO, and we decide for this reason to spend money in welfare state. No? It was possible. Why? Because we are, this is not only my idea, we are in a defense alliance. And this is very nice because when we have a tension with Washington for space activities, we must to pay attention because our space activities, not only this, but generally several technoscience policy in Italy, are linked to the relationship, the special relationship with the USA. And this is a strong argument to be very careful when we speak in Europe about the relationship with the United States. Last but not least, he quoted very nice this example of today in Italian Embassy in Canada, the mission of the ENFN. Today, ENFN or INAF, the National Institute for Astrophysics, they are actors in Italy for science diplomacy. It's not hazardous. Then we had some senior official came from the Italian National Institute for Nuclear Physics in Erice, in our school. Yes. And this school was organized in Erice, you may see by internet, in cooperation with the Italian CNR. The Italian CNR was born in 1923 to give advisor to the government for technoscience. And CNR now has a leading role in Italy for science diplomacy. All these things are very interesting because when we study Italian foreign policy today, and also in the past, we must to underline very well that we have several actors, not only the big politicians, Giulio Andreotti, Bettino Craxi, no, too, with archives and their foundation also, the archives. Behind them, there were Giancarlo Setti, Cesare Pacini, other guys, other scientists who worked to reinforce the position of Italy by exploiting, by using the fact that Italy was inside the European integration process thanks to De Gasperi and thanks to several politicians. Also, they use the fact that Italy was in a strong alliance with USA. Several scientists go in USA to study after the end of the Second World War up to today. This is very relevant, very, very important. And this is thanks to the fact that Italy is in this framework of international relations. Thanks so much. I think we may finish here. We will see tomorrow if you want. Thanks so much to Dr. Rocci.
Thank you very much.
Grazie davvero. Grazie. Arrivederci. We may stop our connection.
Okay.
Grazie. E poi una comunicazione.